Hello student, welcome to today's session. So today we are into the fifth session of organic series, and in today's session the objective of today's session is to have a problem solving based on the last 2-3 sessions. So we would be doing some questions given as an homework and some new questions. So this was the question which we asked you in the last session, that degree of unsaturation for cubane. Cubane is a compound which is being shown like a cube, for which we are supposed to find the degree of unsaturation. So here 2-3 things which you have to keep it in mind. One way is that you just would see that all of these corners are carbon, and all of these carbons are having 1 hydrogen as well, because to keep the tetravalency intact, so there are 1 hydrogens as well. So one way of doing is that you, as we said in the last session, is that degree of unsaturation is the sum of all the rings. Now in a cube, if I would go for the rings, if I just would make it once again, that is why I said last time also, counting rings can become little deceptive, because here you could see this is the first ring, second ring, third ring, fourth ring, and fifth is the front one, and sixth one is the behind it, because in a cube there are 6 faces. So many of you can opt for the answer as to be 6, but that would be a wrong one. So if I would go now, just see the way I am going to pick this question. So it is C8H8. One way of doing is this, because you just have counted the carbon atoms and hydrogen atoms. So C8H8, and then you just would put the degree of unsaturation into the formula. So 2 into 8, 8 is the number of carbon atoms which we discussed in the last time. 2 plus nitrogen is not there, halogen is not there, so I shall have to do minus 8. So it is 16 plus 2, 18 minus, so this comes out to be 10 by 5. 10 by 2, so answer comes out to be 5. So degree of unsaturation for this compound is 5. Other way to say the same thing is that if I just would write this is C8H8, every carbon is having 1 hydrogen. Now if I would just go from this side to this side, by making a bond cleavage here, if I would break it from here, so I have broken the bond, but this bond can be broken, and then to keep the tetravalency intact, I have to place 2 hydrogens. So this means I have just added 1 hydrogen into this system. And similarly, if I would keep on going it like this, then I have to break this bond, then I have to break this bond, this bond, and so on. So in doing so, once you reach to a alkane, you end up getting almost you have added 5 moles of, or 5 molecules of hydrogen, or 5 pair of hydrogen atom, to make this a compound of cubane into alkane. Now let me do the another thing which we have asked in the last session also, that in this question we said about that which of the following is formed or are formed when cubane is completely hydrogenated to alkane. So if you are having with you a cubane and you are supposed to add all the hydrogens into it, what maximum number of hydrogens you can put into it is 5, isn't it? We just have found the degree of unsaturation is 5. Now the beautiful question it is, now this is the cubane which we have just spoken about. Now if I just would do skillfully that I just have broken this bond, say for example this bond. So if I have broken this bond, it already had 1 hydrogen which is being shown here. There are 2 hydrogens already. But if I have broken this bond, I have to place 2 more hydrogens into it, isn't it? And similarly, so this means I have added one molecule of hydrogen, or 1 pair of hydrogen atoms. Now if I would go further, I just have broken this one also. I just have broken this one also. Wow, beautiful it is. I have just broken this one also. I have just broken this one also. So let me redo what I just am saying it to you all, is that we started with this. So here if I just would break this bond, I have to place 2 hydrogens, or 1 pair of hydrogen atoms. So 1 hydrogen molecule went here to break this particular bond, isn't it? To break this particular bond, I just have added hydrogen. Similarly, if I would keep on going it like this, I can have to break this one also, this one also, this one also, this one also. So how many hydrogens I have added? 5 hydrogens. Now you could see what this molecule would be. 1, 2, 3, 4, 5, 6, 7, 8. So interesting it is. So it is nothing but octane. Is it it's a straight chain. alkane. You have just made the alkane. But some other fellow can break the bonds like this also. That there you have the liberty of doing that, because you have to break 5 bonds out of it. You have to add 5 hydrogen, 5 molecules of hydrogen into it. So somebody else can do it like this also. You broke it from here, 1, 2, 3, 4. Oh, sorry. 4, and then this one is 5. So in doing so, now you just count the number of carbon atoms into it. The longest chain which I am seeing here is 1, 2, 3, 4, 5, and 6. Now if I just would make it a more in a easier way to interpret, the first one is this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. This one is this. This is this one. Now what is this? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. On to the third carbon you are seeing methyl. On the fourth carbon you are also seeing methyl. So how many methyl do you have? One methyl is here and one methyl is here. Is it okay? So both are one and the same thing. So what I'm trying to say here is that if in case I just would add 5 hydrogens into it or 5 hydrogens into it, I may get with this one, I may get with this one also. There can be one more combination also. You have to again remove the 5 bonds, 5 bonds in such a way that you are adding 5 hydrogens into it. Thereby you are breaking every bond. Here what I can do here is, now just see here, 1, 2, 3, 4, 5. Beautiful it is. Now if I would see the longest chain into it, 1, 2, 3, 4, 5, 6, 7. So I may write 7 like this, 1, 2, 3, 4, 5, 6, and 7. On to the third carbon, I could see there is methyl here. So that in a way shows this thing very interesting, that you can break it from any direction, isn't it? Because they are not saying us which way it has to be broken. So you can break it from any side. So on hydrogenation, now let me do this question. So first I would have checked how many carbons did it have. So the carbon atoms are 6. Carbon atoms are 6 and Du is 0. So here also the carbon atom is 6 and 2 are methyl, so total is 8. So this also is C8H18 because there are 8 carbons with no degree of unsaturation, and this also is the longest carbon chain is 7 and 1 is the methyl. So this means when you hydrogenate cubane, so this could be a typical JEE mains type or NEET type of a question which can be asked in the paper. So the answer to this question would be D. All of these can be formed because they haven't said which way I have to break it. So it can result in any of these 3 combinations. So it was a good question. Okay, going ahead. Next question is number of possible structural isomers having one ring for this compound. So this type of question we did in the last session, where I talked about a bit of discussion I have done for the isomerism. That isomers are the structures, isomers are the compound which are having the same molecular formula, but structurally they can be different. So now for this first, as I said, we have to find the degree of unsaturation. So 4 into 2 plus 2, nitrogen is not there, hydrogen is there, so minus 6 minus 2 upon 2. So this comes out to be 8, 10. So this degree of unsaturation came out to be 1. What I did is, degree of unsaturation is found like 2C plus 2 minus plus nitrogen minus H minus X upon 2, where nitrogen is not there, hydrogen is the hydrogens are 6 in number and halogens are 2 in number. So this is the way we have found. Now the degree of unsaturation came out to be 2 in this case. Now what is the formula? C4H6Cl2. Now degree of unsaturation is how much it came out to be? It came out to be 1. So that means this compound either would have 1 pi bond, it can have 1 pi bond, and that pi bond shall then be in C double bond C, or it may have one ring. It may have one ring, and he is asking us about the ring. So you have 4 carbons with you, so I can join 4 carbons like this, isn't it? So making 4 carbons like this in a way endorse this thing that the degree of unsaturation has came out to be 1 only. Now you have to place 2 Cl into it. So I just would use the line representation, bond line representation. so that you would feel more accustomed with. So this is 2Cl, or somebody else can make it like this also. Let me first draw the four some structures like in the ring of 4. And now one way is, this is, you have placed 2Cl onto the same carbon, which I have said already in some other session that it could be said as a geminal dihalide. Geminal dihalide is the one where two halogen atoms combine joins at the same carbon. Now another combination you can generate, this one. This is, we said in the last session, I think in the last to last session, vicinal dihalide. So these things you keep on adding in your knowledge bank, because sooner or later we have to discuss this in detail also. So one way is this, another way is this. So I think with the ring of 4, I can get these 3 structural isomers. This do engage stereoisomerism, which is not the part of discussion at this point of time. We will be discussing in the once we do the GOC or things like that. Thereafter in the isomerism we will take up that. So as a matter of fact, here the endeavor is that how can I place this particular formula in different forms. So one way is this, keeping the ring 1, because that is what it is being asked with. Now we are left with a ring of 3-membered. So 3-membered ring, I can make it like this. I randomly is making 3-membered ring like this. Now already du came out to be 1, and you still have to place 1 methyl. So this is 1 methyl. You can place 1 methyl like this, and now you have to place, I'm just making it, let's see how many can be generated out of it. Now you have to place 2 Cls. So 1 chlorine can come here, 1 chlorine can come here, one combination is this, or 2 chlorine can come here. That could also be one of the combination. And another combination which I may get is, I think this one, this is also possible. This is fairly possible. And if I just would do the 2Cl here, this got repeated. This got repeated with this one. And if I would keep 1Cl here, 1Cl here, this also got repeated with the structure number, this one. So is there any other combination possible? I could see one more. So if I make this as CH2 and this, bring it here, Cl. So this in a way also would have the same molecular formula, because degree of unsaturation is 1, carbon are 4, and Cl is 2. So I have to place 2 Cl. So 1 Cl I can place it here also. Now you could see that in doing so, I could get many number of compounds from this particular entity. If I just would make it like this, I could get with few more combinations. So just see, the question has become so interesting. You have to place 2 Cls, isn't it? So if I just would keep on counting it like this, so it is 1, 2, 3, we already did. This is the 4th one, this is the 5th one, this is the 6th one, this is the 7th one, this is the 7th one. Now if I keep on going it further, this is the 7th one we just have made. And now you can make it this one also. This is 8, this is 9, and this could be 10, and I think I have not missed anything. So let me check the options, what type of options they have given. So they said number of possible structural isomer having 1 ring for this compound could be how much? So definitely it would be more than 5. So here the examiner is only checking us that would I be or would you be able to make more than 5 structural isomers for this particular formula. So we are able to make it. So there is no, as many of you people keep on asking this sort of a question, is there any shortcut for this? There is no shortcut. You have to actually make it in the paper in a speedier way. And if they have categorically asked you the total number, then you have to do it very patiently so that you would not miss any structure. Okay, next, going on to the next problem. The smallest alkanes have the general formula this, having 1 not carbon, 2 not carbon. This discussion I have yet not have placed in front of you. Let me do it speedily with you. So there is a term called as primary carbon, secondary carbon, tertiary carbon, and quaternary carbon. Primary carbon is the carbon which is attached to a carbon attached to 1 carbon atom or none carbon. A carbon which is attached to one carbon or no carbon is said as primary carbon. Similarly, a carbon attached to, I may write it here, a carbon attached to two carbon atoms is said as to be secondary, two not. And similarly, a carbon attached to three carbon atoms is called as tertiary. In the same viewpoint, if I would have to write the quaternary, a carbon attached to four carbon atoms, carbon attached to four carbon atoms is called as quaternary. Just like if I would show it like this to you, just randomly I made this structure. Now in this case, this carbon is attached to one carbon, that is this carbon. So this would be said as primary carbon. And this particular carbon is now joined to two carbon atoms, which I am showing it with the yellow marker. So this would be said as secondary carbon. And the one which I am now showing it to you is this one. This carbon is attached to three carbon atoms. What are those three carbon atoms? One is this, 1, 2, 3. So this would be said as tertiary. This is said as primary. Why is it said as primary? Because it is attached to one carbon only. Let me do it once more for you. If I have drawn this structure, this would be said as primary, this is primary. But soon I just would make this second carbon as to be secondary because it is attached to two carbon atoms. Now if I would make one carbon here, so this has become tertiary. Is it okay? So this is the way it is to be dealt with. Now if I would make it like this, say for example, somewhere you have shown this structure. So here what I will be saying here is this is CH3, CH3, CH3. So all these CH3, this is said as primary, this is primary, this is primary. Why? Because this particular carbon is attached to one carbon, which is the quaternary one. Because why I am saying this one is quaternary? Because it is attached to four carbon atoms. What are those four carbon atoms? One is this one, another is this methyl, another methyl, another methyl. So this would be a quaternary carbon. So I think it is quite easy, not a difficult one. Now what the fellow is asking is this question. You are being given these compounds and these compounds are nothing but alkanes. So you have to see a smallest alkane having only primary and quaternary carbons. You have to make that alkane which just would contain only primary carbons and secondary carbons of quaternary carbon. So if I have one carbon, if I have just one carbon, I would say it as primary because it is not attached to any carbon. And if I would make it got attached with another carbon, this is again primary, this is primary because both are attached to one carbon. Now if I just would make it this way, this is primary, but this has become secondary. And if I keep on going it like this, if I just would attach one more carbon here at the center, so this has become tertiary. And all of these three are primary. Now what the fellow is asking, you should have a smallest alkane which would contain only primary and quaternary carbon. So now the answer is very close. So if I would make it like this, because this is primary, 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 and this would be quaternary, isn't it? Because it is attached to four carbon atoms. So what is this formula? This is nothing but the 5 carbon and du is 0. So this endorses the point C. So C would be the right answer for this question. So C is the best answer. Where you have a smallest alkane which is made up of only primary and quaternary carbon. No other carbon, other type of carbon is not there. Secondary carbon is not there, or I would say tertiary carbon is not there. Okay, moving ahead, let's do one more question into it. Which of the following formula has maximum number of covalent bonds? So this is a question which we have, this sort of question we have done in the last sessions as well, where we talked about how to count the number of covalent bonds for a given formula. And I just would suggest you just to find out in this particular question as well, another type of question can also be asked for these four options. Find the one having maximum or minimum as per the taste of the examiner, maximum or minimum degree of unsaturation. This could also be asked in this particular question. So here, if we go by the formula where we have already talked about that the number of covalent bonds is electron demand minus electron supply divided by 2. For this discussion, those who are seeing it first time, so I just would request you to go through on a 2x speed on to the session number 3, where you would get with the discussion of this formula, how this has been operated with. So here you have 4 carbon atoms, so I just have taken this as 4, and the maximum electron carbon would want has to be 8. So the demand is of 8 and hydrogen are 10 in number. So every hydrogen want to complete its duplet. So 10 hydrogens would want to take 2 electrons. So total becomes 52. So the demand is of 52 and here electron supply is the number of valence electron. So we have 4 carbon atoms and 4 carbon atoms are requiring 4 electrons, are having 4 valence electron, and 10 carbon, every carbon is having 1 valence electron. So total becomes 26. So this, if you would calculate the number come out to be 13. So if I would do it in a speedy way, just to make you comfortable with the other viewpoint, so degree of unsaturation, if you would find for this, is also 0. So that means there are 4 carbon atoms which can join it like this, or 4 carbon atoms can join it like this. Now if you would place the hydrogens into it, so all these yellow bonds which I am showing, these are going to get attached with the hydrogen, isn't it? So these are the hydrogen. Now if you would calculate, this would come out to be 13 only. And similarly you would see into this one also, this also is having 13. So this particular compound, with this formula, I got this knowledge that how many covalent bonds are there, and with this formula, the formula of du, I am able to tell you that what type of bonds do we have in this formula. So all bonds in it, all bonds are of type, tell me what would be the answer, would be the type of sigma bonds. There is no pi bond in this particular structure. This is other way I am placing the things in a speedier way. So similarly, if you go for this formula, do the calculation yourself and you would get with the 14 as an answer. And if I just would want to ask you the degree of unsaturation, so it would be 2 into 4 plus 2 minus 8. Oxygen is not to be counted, divided by 2. So this comes out to be degree of unsaturation as 1. So this particular compound C4H8O2, if you just would make all the possible structural isomers for this, all the combinations, just like if you have 4 carbon atoms and you are going to place 2 oxygen atoms, so this is the one popular one, carboxylic acid, then you could also place it like this. So there could be any number of combinations possible, 1, 2, 3 and 4. So there can be this way also. These are what you call it as ester. The functional groups we are going to do in the next session. So what my endeavor is to tell you that two things are very interesting and important, which I taught you at the very upfront, is how to find the total number of covalent bonds and what nature of covalent bonds could be there. Are all those bonds in that formula are sigma, or some are pi, or is there any possibility of generating a ring also? That is coming from the topic of degree of unsaturation. So similarly, if I would go for this formula, in this the nitrogen came, so the formula had been the carbon is 4, so it is wanting 8 electron, hydrogen is wanting 2 electron to complete its duplet, nitrogen is wanting 8 electrons to complete its octet. So the total demand is of 62. And what is the electron supply? Nitrogen is supplying me 5 valence electron, hydrogen is supplying me 1 valence electron, carbon is supplying me 4 valence electrons. So total become 32. So if you would calculate, this comes out to be 15. Again, if you would find out its du comes out to be 0. 2C plus 2 minus plus N minus hydrogen minus X is the formula. So here you would able to see that there are 4 carbon atoms, 4 into 2 plus 2, nitrogen atoms are 1 and hydrogen atoms are 11. If you would calculate it out, this comes out to be 0. So there is no pi bond here. So this is again very interesting question. And similarly, if you do the calculations again yourself, so this comes out to be 14. So for this is 14, for this the C would be the right answer, because it is having the maximum number of covalent bonds. So the answer to this question would be 15. So I think I made my point clear. So these are the some of the questions which I wanted to share it with you. Hope you liked the session, and in the upcoming session we will be discussing about the homologous series and different I shall be giving you awareness about the different types of function group, and thereafter we will reach on to the topic of IUPAC naming. So do comment on to the channel if in case you find something other than the way I am passing it, the content, are you liking it, or anything which you want to share it with me. It would be so nice, and it would really motivate me in making these videos more aggressively for you people. Thanks a lot. Have a nice day. Stay safe and take good care of yourself.